Okay, so let me try to explain the simulation for this sets and points. Remember, we have gamma equals m over a, phi equals n over a. N is the number of sets, and m is the number of points. All right, so we're going to have a square with, I think we decided that sets goes on the x-axis and points go on the y-axis. So you see we have parameters here, m, phi, m, n, little a, and big A. So how are we going to choose those? Now we want to choose them so that the simulations don't take too much time. All right, I think I decided to change these ratios a little bit. Instead of 1/3 here, I want to make this 1/4. So I'm going to go and change this to 1/4. So I want the values of MA and NA to be between 1/4 and 5/4. I think that will be a good summary, because once it's over 1, I think things kind of settle down and you never get islands anymore. So I'm thinking that 1/4 to 5/4 will be a good range. And going down to 1/4 will show us how the behavior gets started off. All right. Okay, so I'm going to take A over A. I'm going to take that to be, well, let's see. I said 4,000, but we may change that. So here we have A is equal to 1. Now, so I want M and N to be between 1,000 and 4,000 and 5,000, right? In order to make, and if A over A is 1 over 4,000, then M and N have to be between 1,000 and 5,000. So let me take the minimum of M and N divided by 1,000. Now, why am I doing this? Because I want to make sure my simulations don't have too many have too many sets and points in them. If I take both M and N be 5,000, that's a big simulation. I'd rather do another simulation that has fewer points that gives the same result. Now, since MA over A and NA over A are the only parameters, I could find a different set of A over A such that it says that gamma and phi are the same. So this is what I'm going to do. I take Q equals M equals the minimum of Mn over 1,000, and instead of taking A, I'm going to take A prime is A over Q, M prime equals M over Q, and N prime equals N over Q. Now, why do I do that? Because then if I take the gamma, which is MA over A, okay. Now, if you look at what that is, that's the same as M prime times A prime over A. So in other words, instead of using M and A, I can use M prime and A prime. And those numbers may be smaller. Okay. Instead of using phi, I'm not going to use this A over A, but I should say this is the target. This is, well, because I'm not actually going to use A over A in my simulation. I'm going to use A prime, and I'm going to use M prime, and I'm going to use N prime. So as I started to say, my phi, which I want to be equal to NA over A, well, if I use N prime and A prime, that's going to be the same thing. Now, why do I do this minimum? Because this will guarantee that M and N will be bigger than 1,000. I don't want M and N to be too small, but I want to make sure that M and N are at least equal to 1,000 so that my simulation has a adequate number of sets. Okay, so that's what the procedure is. You can loop. M goes from was going to go from 1,000 up to 5,000, and N equal 1,000 up to 5,000. And I suppose we could take 25 steps. Okay. If I take 25 steps, that's going to be 25 times 25, or 625 simulations. Okay. That might be a little bit too much, but we might have to scale that back down a little bit. But I think that may be a reasonable goal. Maybe we take it down to 20. Okay. So for each value of M and N, I'm not going to use M and N. I'm going to calculate I'll calculate Q equals the minimum of m and n over 1,000. And then I will take A prime, as I said, I'll take A prime equals A over Q, A prime equals A over Q. I'll take M prime equals M over Q. And I'll take N prime equals N over Q. And I'll run the simulation with A equals 1. Big A always stays 1. And then A prime, M prime, and N prime. Okay. Now this simulation will have the same ratios as if I used A, M, and N. Okay? And then we'll store this value associated with M and N. Okay? So if we do 20 steps apiece, that's going to give us 400 values. 400 sims, 400 values. All right. I'm not sure exactly how many sims it will take. So let's suppose you can test one simulation. Okay. For instance, if one simulation is 1 minute, all right, then see, I'm really not sure how long one simulation takes, but if one simulation is 1 minute, then if I do 600 simulations, that would be 600 minutes. That's 10 hours. That's kind of reasonable. Up here, I'm suggesting 400 simulations. But I'm thinking that if we do, this is something, once we get this straight, we should run overnight. So maybe 600 is a good number. So maybe 25 by 25 will be okay. It depends on how long the simulations take. I would choose a simulation so that it takes less than, say, 12 hours. Right? So that's kind of my discussion there. We can talk about this further next time we meet.